if we have a carboxylic acid, here's a carboxylic acid, C double bond OH, or if I have an amide or an ester, C double bond OR is an ester, C double bond O NH2, those do not readily enolize. It's because the lone pair next to them already is donating electron density in. So it's not particularly favorable for them to undergo enolization on their own as it is. So they don't enolize enough. And in order to do one of these acid-catalyzed alpha halogenations, we have to react it by the enol. So instead, what I do, if I want to say alpha brominate this carboxylic acid here, I'm going to react it with Br2 and PBr3. That's the difference, where before with just the ketone I'd do Br2 and acetic acid or something like that. So that, as our first step, performs an alpha halogenation in water, as it turns out regenerates the carboxylic acid. So let's look at how this works first. PBr3, just like thionyl chloride, it turns a carboxylic acid into an acid halide. Right? So PBr3 is what converts C double bond OH into C double bond OBr. Now that I have an acid bromide, that can be enolized. Those electron donating groups on those other compounds didn't allow enolization, but bromine is electron withdrawing, so that's helpful to us. We have this acid bromide enol, which then can undergo alpha bromination. If you're following the color codes here, the alpha hydrogen in the acid bromide goes on to become the OH hydrogen in the acid bromide enol. So this other one should not really be colored red. It should just be black like that. Okay, those two are essentially equivalent. So the bromine adds to the alpha carbon. So now I have what's called an alpha bromo acid bromide. Sort of a mouthful. Alpha bromo acid bromide has two bromines in it. Right? C double bond OBr and then CBr next to it. If I then react that with water, it does what any acid bromide would do. It's hydrolyzed. So the acid bromide is hydrolyzed with water. It makes the alpha bromo carboxylic acid as our product. So let's look at that just one step at a time again. Okay? The PBr3 makes the acid bromide. That can be enolized, which then the enol reacts to form the alpha bromo acid bromide. Okay? Water then gets rid of the bromine attached to the carbonyl, but the alpha bromine remains behind. So that's called the what's called the Hell-Volhard-Zielinski reaction, HVZ. HVZ reaction. I can never remember those names because we always refer to it as HVZ. So use that with a carboxylic acid or something with an electron donating group attached, like an ester or an amide, for instance. An interesting variation on that is that this water reaction at the end is not mandatory. Instead of hydrolysis, we can undergo carboxylic acid derivative reactions. So if instead of water I reacted it with alcohol, I could make an alpha bromo ester, right? Or if I reacted it with a carboxylate, I could make an alpha bromo anhydride, or an amine, I could make an alpha bromo amide, and so on. So all of our reactions from the previous chapter apply in this very last step of the HVZ reaction. It just so happens the common way of doing it is hydrolyzing, because then you get back to the carboxylic acid that you started with.